Welcome to our next project, and before anyone says it, yes, this is a knife. I know that this is a gun-related YouTube channel, but yes, we are going to build a knife. But there's a gun-related reason why. Before we get too deep into this, let's do a quick thank you to Speed Tiger for helping us make this video possible. I really want to do some work on Glock slides, lightning cuts, serrations, that sort of fun stuff. But those are generally made out of stainless steel, which is pretty difficult to cut from what I understand, especially if I've never cut any steel before in my entire life. So we're going to start with a much easier steel, in this case 1084. It's cold rolled, it's annealed in the condition that I bought it, perfect for knife making, and it's fairly forgiving, especially compared to stainless. Real quick, credit where credit is due. This is a smaller, thinner bladed version of a really cool knife by a maker named Chris Reeve. So if this is interesting to you, check it out. Lastly, I'm not going to show you how to design a knife. I will put the link to the video that I used that taught me how to put this drawing together. So if you want to learn how to do that, you can go do it over there. But let's go over to our manufacturing workspace and start talking about the way that we're going to cut this out. The first thing that we're going to do is we're just going to clamp it in our vise, and we're going to drill out some holes. I don't have a good 4mm drill bit, and that's actually the bit that we need for little attachment things that we'll see later. So I cleared it out with a drill bit slightly smaller than a 4mm, and then I came in with a 1/8 of an inch bit to bore out the larger one, which is going to be our sort of lanyard hole at the back, and do just a contour on the 3 holes that we're actually going to put pins through later. If you want to see what my feeds and speeds look like for this 1/8 inch 4-flute bit from Speed Tiger, that's what I was running for the bore, which I considered more of a helixing down operation. And then same bit, but slightly different method of approach here for just full depth, just taking off, I think it was like 10 thou to make that hole perfectly sized. That's now going to allow us to put it on a jig. And so all the jig is the knife on a known sized platter that we can again hold in our vise, and it actually has 4mm threaded holes under each of the places the knife is going to sit, and that allows us to clamp this knife down to this this jig and cut things out. If you're clamping over an unsupported area, be sure to add something below it with upward pressure so that you don't bend your material. I left 20 thousandths of an inch of thickness. Right now seems a little thick to kind of pop the knife out. I may come back and recut that, we'll see. But let's talk about that profile because something very interesting happened. I came through and I did a full slotting run around the outside, leaving a little bit on the edges. So you can see what again, same bit as before, but again, I'm now using a different preset with some different values here. And I left, what was it? Yeah, I left 15 thou radial to come back and cut off. With a subsequent pass here, and again, same bit, but this is my finishing pass. So I did a slotting and then a finishing with different feeds and speeds. Found was, and I'm doing two knives actually, what I found was that the first knife that I did, I accidentally had the Tormach set to run the feed at 150% of what was programmed. So it ran decently faster than what I showed you right there. And it worked great. I then ran the second knife at the actual feed that I'd programmed, and it still looked great. So I don't think I'm pushing these bits as hard as I can. The other reason I say that is I also went and did two different styles of roughing and finishing for the bevel shapes, the 3D paths here. Basically, the first try I used a 1/8 of an inch bit, a ball nose bit, this one here, again, Speed Tiger 2 flute Altiban bit. And I went in and used this profile to do my roughing of the whole thing in two different paths to step down. And then I came back and did a finishing pass with these speeds. And I think that finishing path took off 10 thou of depth and with a 10 thou step over. Oh my God, this was slow. Like, it took about 40 minutes to run the finishing path for both strategies. And I say both because the second knife I did, I came in and I did most of my roughing in a single depth pass with a 1/4 inch bit of the same type. And yeah, it was bigger. I left more meat in the step overs, etc. It was also very slow. So no matter how I roughed it out, I still wasn't as fast as I thought I could be, and I still paid a huge price with that final finishing path with the 1/8 of an inch ball nose bit. I think I'm going to use a slightly different strategy when we flip the knife over and do the bevel from the other side on our jig as well. But let's look at what we've got. Here are the two knife blanks, and despite the two different ways of tackling the 3D paths and the two different speeds for the channel, they look pretty much identical. Let's start by looking at the actual side finish here. Probably the best place to look at the finish for our slotting and our finishing pass is where the bit exited out the side of the blank. And as you can see here, there's really not a difference in finish quality on either one. And that's the 100% feed that I programmed versus the 150 that I accidentally ran one of these at. So again, I think I'm not pushing the bits as hard as they can go. We will test that theory out, at least for 3D paths, on the other side in just a little bit. The other thing I want to note is, yes, even with a 10 thou step over and a 10 thou depth of cut, this finishing pass does still have a decent amount of texture to it. That's fine. Most knife makers are actually cutting out the blank and then hand grinding in all of these bevels. So there's going to be work prior to heat treating to true this up no matter what. And there's going to be a little work after heat treating to polish this up and sand this up anyway. So we're not looking for a 100% perfect finish on the bevel. We're looking to just remove a lot of the material and minimize the amount of work we're going to do because I don't have a grinder or a knife style belt sander. Actually, I'm gonna take back one of my comments. This knife, although I haven't cleaned up the blank as much, so there's some schmutz in the channel, this knife is the one that was run at 100%. And if you look in that channel, there's some lines, tick, 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 tick. Whereas this channel, there really aren't any of those lines in there. So I actually think it's a smoother cut at the higher feed rate. So definitely something to watch out for. Let's talk results. This was strategy 1, where everything except for just that little very tight curve at the inside was done with a 1/4 of an inch ball nose bit. It may look like a bigger pattern than this, but this actually feels smoother to me. I don't know if that's because of just a large bit and how circles work, or because it's in this direction instead of perpendicular, but this was much faster, like ridiculously a lot faster, and I like the result better. Now, one thing I don't like is how that result was here. I like that section done in the perpendicular pattern. You can see what that looks like. This is better. Yeah, there. See, that's much nicer in my opinion, right in here. But I think probably the winning strategy that I would go back to is do the 1/4 inch ball nose bit exactly like I did it here, and then do a perpendicular finishing path with the 1/8 inch ball nose for just that one little section. I think that's the win. This strategy 2 here just still took way too long. And although I do like the results, just not efficient. The other thing to keep in mind is while strategy 2 was milling, I tried to break the steel excess off of the strategy 1 knife, and it was a nightmare. I might as well have not CNC'd the knife. I was ending up just, manually filing a ton, and then in sections where it wasn't straight, like here, and you're trying to break it off, it was almost impossible to break off. So I went back and I ran a path to cut off the excess on strategy 2, and then I actually bolted strategy 1 back to the table and I cut off all the trash that was left over even after filing and ripping off. The one place that I didn't do, because it's not supported by any screws or anything, is up here around the actual knife, but I don't foresee problems there because the only place that it's connected is this straight line across the back with a little bit of the tip. Well, I'm not completely done. I have done enough smoothing of the 2 blade surfaces to know which one I prefer. This one which is the 1/4 inch ball nose bit strategy where I just did everything in a pass. This took half the time, and I used 120 grit sandpaper. This was our 1/8 of an inch ball nose strategy, and this took twice the time, and I was using a file. So faster, more efficient, better finish result. I'm not super happy with my feeds and speeds and strategy on the bevels completely. I'm still doing more work than I would really want to, but if I had to choose between the two, I'd choose this one. So for a future knife project, this is where I'll start and improve from. I know I'm wasting effort by sanding up past 120 grit prior to heat treating the blade. However, since this blade will be Cerakoted and I haven't decided if I'll send it out for heat treatment or try and do it myself, I wanted to make sure my sanding and blasting process would lead to good results prior to potentially sending it somewhere. So here is both sides of the knife bevel sanded to 120 grit with a hard backer. I then used a Dremel sanding wheel to chamfer all the back half's edges. If you look closely at the knife I'm emulating, it had these subtle rounded edges, and then the wood handle was actually inset from that, adding a cool classiness to it. This chamfer, coupled with sanding the edges to 120 grit backed simply by the pad of my finger, which is soft, helped reproduce that look. I then hardback sanded the bevels to 220 grit, flattened the main faces on my diamond stone, and then sandblasted it. If the process goes similarly after heat treating, I should be just fine for Cerakoting this later. Next episode, we will need to make some handles for this thing.